We now move into the first of our four-pillar plenary sessions, and this afternoon, we're focused on products. This pillar is all about the features and quality of the materials, fittings and appliances used in plumbing work. The world market for plumbing products has never been as big, diverse, fluid or dynamic. With an estimated value of more than $800 billion and growing year on year, product expansion combined with lower trade barriers and rapid demand growth from large economies such as China and India means there are enormous economic and development opportunities within both emerging and established markets. There are also more risks. A booming market can attract substandard products made from inferior and unsuitable materials. How do we help industries put systems and processes in place that allow only properly certified products to enter the market without stifling innovation? This is very important in developing economies, where the ability to access new and innovative products such as contemporary backflow devices is key to improving health and economic outcomes. It's now my pleasure to introduce Dr. Steve Cummings. He's the Director of Innovation at GWA Bathrooms and Kitchens. Since 1980, he's been involved with the research and development of innovative, sustainable bathroom and kitchen products, with a long-standing commitment to water conservation and related advanced drainage research internationally. He's responsible for Caroma Smart Command, which we've heard about already and we'll hear about more in the next couple of days, a unique ecosystem of IoT bathroom products that are monitored and controlled at varying levels via data connectivity to Caroma's cloud-based services. This advanced capacity provides significant opportunities for reductions in commercial building water usage and energy, presumably as well. He was inducted into the Design Institute of Australia's Hall of Fame in 2012. He's a Fellow of the Design Institute of Australia and Doctor of Environmental Design in the Faculty of Environmental Design at the University of Canberra here in Australia. Steve will speak today on the topic, Intelligent Plumbing, Evolution of Smart Command. Please welcome Steve.
Thanks, Rob. It's my pleasure to be here today to be with so many friends from not only Australia, around the world that I've been friends with for many years. As Tim mentioned this morning, Caroma of the history of innovation over the last 75 years. And as part of that, today I'm going to share with you my experience with the evolution of Caroma Smart Command. And this was a journey for me over 7 years. And in doing so, I just want to take you back to 1984. So this was the first dual flush toilet I worked on, and that's the Viceroy. Some may know, others weren't even born then when this was done. But this was the start for me on a journey with Caroma into the environmental side of plumbing, where we looked at water conservation. This was at a time when the regulators around Australia and the water authorities were worried about the oncoming domestic demand for water usage, and they saw fixture unit water usage reduction was one way of addressing that issue. So I was on that path. At that time, I worked with some very innovative people, and I learnt the DNA at Caroma. I inherited that from very, very intelligent people that were working there at the time with us. And interesting, the photo there is from a hotel in Adelaide that I stayed in last year, and I was amazed to see the product there in pretty pristine condition. As I normally do, I took the lid off and had a look inside the tank, and they're the original internals still working today. So back when I was learning the DNA, it came pretty clear to us that the plumber was key to making any plumbing product successful, because it's got to be installed and maintained, and it's got to last for a long time without any issues. Those are the existing internals. I remember that we changed from a brass arm to a plastic arm, which is a big development then, as well as dual flush. It's still working today, and that's 30 plus years. So we design around 30 years. And that's just nice to see that product still working in an environment where it's used every day. But that's just a side note to the main part about this was the start of the journey with water conservation for me. And if you look at that product was 11.5 and was using 33 litres versus 55 litres for the original single flush toilet. And we're moving down over the years, various iterations of dual flush in Australia. In 2004, we dropped the water volume to 4.5, 3, which there's a lot of research was done at the time to do that with the regulators. And it stayed that way for the say up till now, but it's a standard flushing volume used around Australia. But importantly, if you look at this water we're saving here is 70%. When I first started with that Viceroy system, ceramic system, into my journey and the company's journey, because it's part of the Chroma DNA water conservation. So pretty significant move, and the iterations along the way were pretty significant and required research. So for the future, we're just looking at where we're going in the future. The previous speaker did mention that. We've been doing research into where the next step is, and in doing that, we're now over the period up until now, we've been doing research into finding this next step. But currently, we've had the Millennium Drought, and now we're moving, I believe, into another drought period. The eastern coast of Australia is heavily restricted by the lack of water coming into the dams, and a lot of rural areas up the eastern side of Australia could run out of water and have water trucked into the towns. But importantly, major capital cities are going to be under pressure as well. Sydney is already on water restrictions, and in time, if it continues, then we're going to have to be building new desal plants to address the issue. But time is a problem, because in the Millennium Drought, the graph going down was like this. Now with the population increase, it's going like that. So we're under stress in Australia. So talking about the research that we thought the next step would come from, we've done research with the regulators and industry groups. We've also done research carried out in collaboration with our friends in the US, PERC, and our Australian group, OSFLO. So it's a group of enthusiasts that we were looking at ways of improving the plumbing system to make it more applicable to low flows. And the research we've done so far has identified areas that we can do that. And one is the vertical junctions and horizontal junctions, toilet paper, and waste that goes down the drain line. So we've done these studies, we've got significant learnings out of them, and also struvite build-up in pipes, which we know about. So the learnings there, I thought we'd be moving into the next generation of water-saving products. However, the next step for us came from a plumbing problem in Melbourne. It's an issue we had 7 years ago, so I usually get involved in the difficult ones. I work with a hydraulic engineer on the project, and we took the urinal off the wall and had the urine and water on the floor, sewer gas coming into the bathroom, shut down the bathroom. And this was an issue where we had to determine the volume coming into the urinal. So to do that, we had to put a pipe on the inlet, dummy rig up the electronic activation so we could flush the thing from the inlet of the hose into a bucket, and then we measured the volume of water. And we both looked at each other after we'd done a few of these, and there must be a better way. So I went back and I looked at a light that flashed if there was an issue with the water volume, or a buzzer that'd sound if there's any issue with the urinal. We tried to do that, but we couldn't do it with the electronics, so we had to completely redesign the electronics to even do that with this unit. And that was the start of our development. We've come up with a better way of fixing a plumbing problem by allowing plumbers, and this was to make the maintenance better, the original concept. And we went back, and what that evolved into was a smart urinal. So we thought most plumbers have got these, so we can communicate through the iPhone, particularly apprentices, the younger guys. And we set about developing that concept, which we did. And we set out to identify the things that I thought were important, that I wanted to know about. We'd already sorted the problem out down in Melbourne, here. And what we ended up doing, so we can measure the pressure coming in and adjust the flush volume to suit the pressure. So if you've got a variation in the building, you can have fluctuations in the flush volume. If the pressure is low, then the flush volume will drop. And this happens all the time in a building. So you can set the parameters into this in the bathroom. So the plumber's in the bathroom setting this up. So he's got the iPhone, and going from product to product, or you can do all products simultaneously in a bathroom. So this is in the bathroom because it's Bluetooth. And going back to what this does versus what I was doing 8 years ago down here, is a massive change to plumbing, which the previous speaker mentioned that we're going to move this way. But it's a good way, and it's not a way that is massively different to what we do now. It's just a more sensible way of doing it. So you can go in there, you can get this remotely, started remotely as well through the building management system. And as we're doing this, we saw other benefits like, well, why don't we get the water consumption from the products off it? Why don't we know, because it's each fixture is monitored, you know exactly what each fixture is doing, rather than just look at the whole bathroom. So we thought it's pretty significant. Plus if you look on the right, we also can talk, you look at the parameters of the unit, you know that the sensor's okay, you know that the battery voltage is okay, you know that the valve is okay. So if there's any issues with this, any of those products, then that can send via the BMS a message back to the plumber. You can tell the plumber it could be a valve issue, it tells you the valve, then you go to the plumbing store and get the product or the component you need, then go on the job, rather than going through what I went through, pulling the thing off the wall and trying to work out what the problem was and iteratively doing the work. So it's a smarter way of plumbing. And while we had the smart urinal, this was early, we thought, well, we'd gone that far with it. We'd taken it from not only measuring the volume, but doing all these other things. Why wouldn't we transfer this to other parts of the bathroom? So we thought, okay, well, we should have a whole ecosystem of products in the bathroom. We put that aside, and then we started looking seriously at building management systems and how to integrate the concept into building management systems. And we came up with a smart command intelligent bathroom system. So it was a bit of during that period, yeah, we did have that eureka moment where we said, well, we've got something here. And we were into the Internet of Things then. When I started, I had no idea about the Internet of Things, but we certainly learned over that time. So it's IoT, what we're doing now. So just an animation. So key key to this product is the shut-off valve system that we've got, that we call the echo valve. So that'll sense any pressure difference in the line, volume difference that's been discharged in the line that's not standard. By Bluetooth, similarly urinal, they'll pick up a leak, go back to the unit, shut the unit down, send an alert to the plumber or building manager. And when you've got those catastrophic leaks that happen in the middle of the night on a Saturday in a building, where they flood through the building and cause hundreds of thousands of or even millions of dollars, depending on what the building is, and we know about them, we know they happen. It'll shut this down and also alert the building manager, but this will be done automatically. The unit will sense there's a large flow coming out of the broken pipe or product or whatever it is. So this is a safeguard of the bathroom. So that's the key to controller of the water in the bathroom. So this is on hot and cold. So with the toilet, as you approach the toilet will light up and it's telling you that I'm here ready to use. It activates touchless by just bringing your hand up to it and selecting the correct flush mode, flush the toilet. Again, everything's Bluetooth, so it's Bluetooth communication to the smartphone for a plumber. We've talked about the urinal. But again, it's smart, it's a Bluetooth adapter that we've incorporated into the system. But again, had to completely redesign the electronics, which has been a significant R&D exercise for us over the years, and get it to work, control it. The basin taps, we've got an in-ceiling unit, a wall-mounted unit, access to maintenance of the faceplate, an under basin unit, all going to the tap, which is got an LED sensor that will pick you up, and like the toilet, will tell you I'm ready for use. There it is there. All the activations in the head, it's pointing down, it's not pointing out, so high-res jackets and that won't activate it. Again, Bluetooth, that's the Bluetooth adapter there. But you just don't put a Bluetooth adapter in, you've got to completely redesign the electronics so it all works. One of our latest ones is the shower, which you can see out there. So it's a glass panel like your iPhone or smartphone. Control the temperature. Turn the shower on. And we're also counting the time you're in the shower and the volume you're using, so you can switch if you want to just see it. Guys like me with glasses, make it easier for yourself. You can see it in the middle. So it also gives you the volume. And that's just one area of operation that I've got there. We've got profiles. We're going to extend this into other highly sophisticated systems that we're currently working on, and greater water conservation as well out of this. So I've talked about the iPhone control. This is at the plumber level in the bathroom, so you have to go to each bathroom. It's Bluetooth. It's not Wi-Fi where the previous speaker talked about hacking. You have to go into the bathroom and hack each bathroom to get access to these products, and from the product out to the building management system is all encrypted. So in the bathroom we've got a gateway. We move into building management system. All the Bluetooth devices talk to the gateway. The gateway then talks to what we call a concentrator, and that can divert into a building management system or the Chroma Cloud. The Chroma Cloud is something we're developing that has got analytics in it, so we can get the data, and the previous speakers have talked about AI, artificial intelligence. With the data, we can do special things and get information that we never had before. So that's an area that we're concentrating on strongly at the moment, to have that capability, and also data back to the plumber. So importantly, and Tim did mention this morning, that we can save 25% of reduction in building water usage with Smart Command applied correctly. And water leaks, well, it's obvious with what we've got and the controls we can put in place to stop water leaks. And also we can identify water leaks. We can identify slow leaks, we call micro leaks. So that the echo valve can sense it can be a drop. You can even sense that volume of water is being wasted. And the other thing for building owners and developers that Chroma Smart Command has sustainability benefits where they can get extra points for their green star on neighbours and well, which is important. That's new technology. It's just an idea just to give you an idea of the things you can do, not that we're going to do this, but you can also, this is a concept where you can have a building occupant that can communicate, in this case with a cleaner. So we've got an app for the building occupant, and one building occupant that can communicate to tell the cleaner, indicate to the cleaner that something needs to be done in this bathroom, or it could be a maintenance issue. They can communicate and get back to controlling their environment they're working in, rather than somebody else doing it. So they can have some control, and this is where it's going to go. In talking to some of the big developers, even controlling the air conditioning, separate to this, where a user control the air conditioning, you can be cold now and you can be adjusting the air conditioning to make that area of the room warmer or colder. It's just the capability of the system and what we can do. Because we're working at a fixture level, so we know what fixture's being used, when it's being used. And in the case of cleaning, they have to shut down the product with the app, with the cleaner's app. You know where they are, and it's a form of geolocation. And it's different to putting beacons. I know that some of these cleaning apps, they use beacons around the building. This does that automatically because you're getting that data anyway. It's quite powerful, particularly for the cleaner. So with the cleaner's app, you can work your way through a bathroom, and because you know at the fixture unit how many times it's been used, say we know the bathroom is the furthest from the door, the least used. So the products. So you can say, well, they haven't been used. Why should I clean everything? Why shouldn't I just clean the ones that are being used, which makes sense. So it's get smarter cleaning, more efficient cleaning, and the cost savings in cleaning, which is the biggest part of cost of a building, are quite significant. And likewise with the maintenance and commissioning. If you know which ones have been used, like the cleaner, you can get, as a plumber, you can maintain it in a smart way. You know, the ones that haven't been used, and you know what hasn't, and how many times. If something has been used 100,000 times versus something that's used 10,000 times, you make a value judgment on which ones you're going to maintain. So the 100,000 one, okay, I'll change the parts in that. Whereas the one down the end that's only done 10,000, there's plenty of life left in that. Rather than going through and changing everything. It's far more efficient, better use of your time, the plumber's time, and you're providing better service to the building manager or the building owner. And commissioning, Chroma specification will be in the app, so when you're commissioning a product, you do it all off the app, and you're getting real-time feedback from the product, where you can just get a tick, it meets Chroma specifications as you're installing these products in the bathroom. And you can you can go for all products, so you can just send a message that all the products in the bathroom are to spec. It'll come back, yep, they are, and then you've commissioned that bathroom. So again, a far more effective way of commissioning a bathroom, and you know that all the products are going to work correctly because they're all set up right, which sometimes doesn't happen. Just give you a little insight into the power of the data that we're getting from the installations. This is for installation. We've been doing trials for the last 3 years, so it's not something we've learned a lot, but this is the data. So while we're having all these great things happening with the products, the data is another area of interest. So it's just, if you look at down the bottom, so it's you've got the monthly consumption per toilet. This is the bathroom. So you've got 6 toilets there. Consumption of urinal and monthly consumption of tap. So what we found was, and if you look at the consumption of the toilet, it's number 1 is the most used, and it makes sense. Number one toilet is closest to the door, so it shows up in the data they're using that more than the others. And moving back to the basin, so wash your hands. And we did a correlation between the use of the toilets and basins, and the basins were used more than the toilets, so that was interesting too. But you can see there that it also going to the basin, which is 4, and going back into the data we're getting, it makes sense. So you go to the nearest toilet, then you go to the nearest basin. Majority were doing that. And just for the exercise. Same thing with the urinal. The urinal closest to the door was the most used. And after they used that, like the toilet, the basin closest to the urinal was the most used. And you say, well, okay, that's interesting, but what use is it? But if you're selling advertising in an airport, then that could be valuable information for you. Not that we're going to be doing that, but it's just an example of the power of the data that we didn't know this before, and that the facility that we're doing this work had no idea of the usage of the bathroom. Patents. So we can do all these great things with Smart Command, but without having properly trained plumbers that can install the Smart Command correctly, then it's an issue. So what we've done, we've installed Smart Command at the new PICAT facility at Narre Warren, where we're expecting the plumbers to be trained in the use of Smart Command, how to set it up, and we'll roll that out as a proper training program in most areas of Australia. So that's the plan. Highly important for us that happens, and also for the industry. So my parting slide is Chroma Smart Command will change the way we use and design commercial bathrooms forever. And saying that, it'll also elevate the profession of plumbing. So you'll be in line with other IoT professionals that are working in buildings. Thank you.